Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Imagine catching data issues before they snowball into bigger problems. That's what Datafold's new monitors do. With automatic monitoring for cross-database data diffs, schema changes, key metrics, and custom data tests, you can catch discrepancies and anomalies in real time right at the source. Whether it's maintaining data integrity or preventing costly mistakes, Datafold monitors give you the visibility and control you need to keep your entire data stack running smoothly. Want to stop issues before they hit production? Learn more at dataengineeringpodcast.com/Datafold today. Your host is Tobias Macey, and today I'm interviewing Burak Karakan about the benefits of building code-only data systems and the work that he's doing at Bruin. So, Burak, can you start by introducing yourself?
Hi, Tobias. Thanks a lot for having me. My name is Burak, born and raised in Turkey. I'm a software engineer by background. I studied computer science, then I moved to Berlin in 2018 to work for a company called HelloFresh. I was thinking I would work there for like a year or two. I ended up working a little bit more than 5. And end of 2023, I quit my job to build Bruin together with my co-founders. We are building, like you said, code-only data platform and tooling around all of that.
And do you remember how you first got started working in data?
Of course. Well, I mean, when I was at HelloFresh, it was I was leading one of the core teams on the software side. We were building we were generating a lot of data, a lot of the events and data that we stored and published was being used by the data team. So I was part of those conversations a lot. But more interestingly, my co-founder and I, we started doing some consultancy for small and mid-sized companies in beginning of 2021, let's say. And that was like the first direct experience to see what are some problems that people are so hurt that they're willing to pay money for, and that's when we started working a lot more with the data. That's when we got exposed to some of the problems, and eventually we ended up building some solutions around those problems. So this was like, I think, my real relationship with data. Before that, I did like a bit of ML, but I was primarily working on the software side and then gradually transitioned to data.
And so, digging into Bruin, I'm wondering if you can describe a bit about what it is that you're building, some of the story behind how it came to be, and who you're focused on as the target audience. Like, who are you solving these problems for?
Absolutely. So a little bit of backstory around this. So when we started working with some of these companies, these were like majority were gaming companies, mobile gaming companies that collect a lot of events. They have like a lot of clickstream data. Their business relies on being able to analyze that data. Sort of one of the first hires they're going to be making is going to be a data scientist or a data analyst. That's like a naive way of, okay, we have a lot of data, let's make sense out of it. But very quickly they start running into data engineering challenges, especially when you think about like the lack of infrastructure and like a gaming company that has never worked with data before. It becomes pretty painful for these companies to sort of make any sense of that data and bring a couple of different pieces of data together to make any analysis. This is when we first got exposed to these problems these companies were having as part of that consultancy that I was talking about. Basically, there was a lot of companies that had data analysts, data scientists, and maybe data engineers that did not have the infrastructure in place, that needed to do a significant investment into their data infrastructure to basically being able to run like a regular query in a data warehouse, So this ended up pushing us towards thinking that, okay, maybe there's a better way. We could build a solution that takes care of the problems of these small teams without having to invest a significant amount of time, effort, and money to making the data usable. That's how Bruin born. When we looked at the market at the time, and I think it still is like the heydays of modern data stack, you had a lot of different tools for a lot of these different jobs. If you wanted to ingest data, you had to host a tool, or you pay for Fivetran or Stitch or whatever. Then you have to figure out a way to transform this data. Then you have to figure out a way to orchestrate all of these. Then comes data quality, then comes governance, then comes observability. All of these were things that in the end, the same team had to deal with, So when we were thinking about, okay, we're going to solve these problems for these teams, these analyst, scientist heavy teams, at the same time, well, it's going to be the same people that has to jump through all of these different tools. Could we sort of build a consolidated way of dealing with data? And that's how Bruin born in the end. Bruin is a company. We have a couple of products. We're an open core product, so we have a command line application called Ingester. It allows copying data from one place to another. It's open source. It's on GitHub. I think by the time the conversation will be released, it will be live. We have a command line application that allows building end-to-end data pipelines, which is also open source. And then we have like a commercial cloud platform as well. But basically, we're trying to build all of these to be built around open primitives so that people can get the benefits of all of these different tooling we built and at least run them in their own infrastructure if they needed to.
To your point of having this single tool chain that goes end to end, I guess it's also worth calling out what is the beginning and what is the end of those points. Like what are the pieces that you're actually focused on solving for? Is it analytical use cases? Is it, reverse ETL? Are you solving for AI applications? There's a wide scope of what a pipeline might do these days.
Exactly. I would say it's primarily the analytical use cases. So what Bruin does is effectively, it is a tool chain and a platform that brings together data ingestion, data transformation, data quality, and governance. So basically, if I were to sort of try to visualize the data stack, so at the bottom, you have like your data warehouse, and vertically on top of that, you have on the right side, you have your BI tool. And on the far left, you have like a bunch of different sources, external sources of data. You have Facebook, Google, databases, whatever. So Bruin aims to fill that gap tries to close that rectangle, if that makes sense. So you have like your BI tool, we don't do anything with regards to like data visualization. We integrate with these BI tools, but effectively anything before that, Bruin tries to simplify and integrate with existing tooling there.
And another interesting aspect of the approach that you're taking, in addition to being code only, is that you are trying to be this unified interface for being able to work across these systems, whereas a few years ago there was the disaggregation of all of the different pieces, which gave rise to the ill-fated modern data stack that has since faded from common parlance. And I'm curious if you can talk to some of the lessons learned in that phase of disaggregation and every tool for itself. And these are the different interfaces. And so everything can be composed however you want, to where we are now, where you're building this single tool chain to try and have that end-to-end workflow, and maybe some of the feedback that you've gotten from people who are starting to use that more unified approach and maybe in juxtaposition to their previous experiences of trying to cobble together all these different tools.
Yeah. So I think like this bundling and unbundling cycle is like very common in every industry. And I think we're going through a rebundling phase in the data industry. But I don't think it's repeating itself in that sense. I think there's a lot of learnings that are being carried over and over. With the rise of modern data stack and individual narrowly focused tools getting deep into what they're doing, was that, okay, you get the best of breed and you figure out like whatever fits into your exact use case the best. But it also came with a couple of problems. So first of all, with that many systems being involved and that many ways of doing things, it becomes pretty hard for anyone to track what's happening to their data. But like where do I get this data from? Who touches it? Who can access it? Where do I use this in the rest of my architecture, etc.? So like that observability was starting to become a major problem. And also like maintaining and building all of these tools and getting them to talk to each other it's an engineering heavy process. Like there's no way to walk around that. I think it requires a lot of knowledge around all of these tools to get them to work together. Another like good aspect of that was it was composable, right? It allowed you to, I don't know much in practice if anyone we're taking up one of them and putting another one back once the stack was built, but effectively you had the understanding that, okay, you can use one tool for data quality, or you could exchange it for another one, and that gave some flexibility. Now, coming into the new way of working, which is like basically trying to understand if we could build a consolidated experience without any sort of lock-in around this. A couple of things we learned was, first of all, code-driven is very successful. Like look at dbt, right? It's like it brings the best practices around software engineering into data workloads. Well, a lot of it is like It comes from like the fact that you treat it as a software, you version control it, you apply all of your regular checks and validations onto that. So that comes to this world compared to the other bundled examples of like Oracle tools and whatnot. Together with that, I think a big chunk of what we're trying to do today is, while building that cohesive experience, how do we make the infrastructure and the tooling we build around them to be composable still, right? It does not have to support every possible way of working, but it should allow flexibility for people to go outside. And the example I always give when I'm talking about this is the drag and drop UIs for building data platforms. It basically forces you into working with the way of the tool, and it practically locks you in if you wanted to move out a year from now. And one of the things that we took as like a core principle when we were building Bruin is, okay, we are going to build an opinionated way of working, but it should also be extensible enough. For instance, we do a lot of stuff around SQL pipelines, but we also allow people to run Python workloads natively. We have pre-built connectors for a lot of sources and destinations, but if there's anything we do not support, or people are not happy with the way we're ingesting data, they could always write their own connectors in Python, or they could write any other logic they want. Or if they wanted to run a very simple regression model, they could write a few lines of Python in the same pipeline without having to figure out or learn a completely different tool. So long story short, as part of that, like all of those learnings, I think we try to take the composability, the extensibility into the new world, while also having like a strong focus on they need to talk to each other kind of mentality. That's why like with Bruin, you can run your data ingestion, you can run your transformations, you can run Python, you can run ML models, you can run data quality stuff, all as part of the same pipeline, same lineage, same observability principles. In terms of like our users, what do they get out of that is basically the amount of time they spend on infrastructure, the amount of time they spend on getting these tools to work with each other is close to zero at this point. And I don't mean this just for like the cloud and whatnot, also for the command line application. You just throw it in a GitHub action, it just does as it does on the cloud platform anyway, which means that you just push, it works natively. You don't need to think about any other bit of infrastructure. It does data ingestion, it does Python, it does SQL, so you get all of those benefits, and all open source, so you're not locked into anything, all lives in your repo, all is based on Git. So basically try to hit a sweet spot of these different concerns.
And to some degree, it brings to mind the original vision of Meltano before they pivoted to focusing more on the Singer ecosystem, sort of as it existed when it was still within the bounds of GitLab, of being this end-to-end tool chain, code first, very DevOps and CI/CD friendly, and as opposed to what you're saying, a lot of these UI-driven workflows or the disaggregated stacks where you have to stitch together everything by yourself, where even though there are these standard interfaces of, you just load everything into your data warehouse, and then you go over to your data warehouse and you do something else over there, and then you go to your BI tool and do something else over there. That led to a lot of edge cases where if you're on the happy path of what everybody else is doing, then sure, it's fine. But if you're trying to do anything even slightly divergent from that, then you're on your own and you're trying to bushwhack through the jungle.
I think a lot of it, there are a couple of things that I think makes like bundling solutions like ours a good time now. There's a couple of advancements, but the most important one I see is I think personas and people are changing over time. One of the things that we're betting on, one of the things that we see with our users is there is a new role, new persona emerging, kind of like analytics engineers, right? Which is like a good middle point between like your data analysts and your data engineers. And these people are going further full stack if they have the right tools. So now these people are highly technical. They can write code. They're not necessarily software engineers. They might not want to build full-blown infrastructure, but give them their ability and they're going to write you whatever they're going to write the code for whatever they need. And I think so we're betting on the growth of this kind of like user persona within the industry, where kind of like what happened to software engineers, give them these right primitives and they're going to start going further to different extents of this. And I think things like AI models getting better at writing code and helping people, data warehouses, cloud data warehouses standardizing on different languages, solutions like SQL Glot existing, for instance, sort of all contribute to making it like the perfect bed for growing a new sort of an integrated way of working with data. And that's what we're focusing on. That's why I think it's a good time to build like a solution compared to maybe 10 years ago.
And continuing on that discussion of when you're within the bounds of what the tool creator envisions as the happy path, then things generally work. But as soon as you want to do something custom, then you have to try and cobble together a whole mess of other solutions. How does that principle factor into the way that you're thinking about the primitives within Bruin, the technologies that you're building on top of, and some of the ways that you have that escape hatch for people who do need to do something custom but don't want to have to throw away the whole tool chain to do it?
So we had a couple of ways that we could go with building these kinds of tools, which the first one was like, okay, focus on transformations, focus on transformation pipelines, focus on SQL, right? And we see this with DBT, we see this with SQL Mesh, we see this with SDF, we see it like with a lot of other tools. Basically treat SQL as a first-class citizen, and then the rest follows, right? But in our experiences, it never worked that way. And we saw that, okay, the moment that you needed to introduce a little bit of Python or a little bit of another language into your pipeline, you had to figure out something completely different, which means you had to host an Airflow cluster, or you need to run Dagster, or you need to run cron jobs elsewhere. You lose the data lineage, a lot of these complexities, right? So we basically built Bruin around the primitives that it's all about an asset. And an asset can be a SQL model. It could be a Python asset. It can be a machine learning model, but it also can be an Excel file. It could be a Parquet file that lives in S3. So Bruin is basically built around the assumption that anything that generates value using data could be a data asset. Hence, it should be possible to represent those assets as part of your pipeline, regardless of where the execution happens, right? So this allows you to sort of separate those definitions from the executions, and it also allows you to expand your pipeline to cover further use cases. And I think a great example of that is Python, right? So you can write whatever you can do with DBT, you can do with Bruin as well, but you can also step outside of SQL with Bruin's built-in like Python abilities. For instance, when we're running Python locally in your computer, we install the Python distributions. We set up a virtual environment. We install isolated dependencies there. We take care of all of that complexity. So you just write a few lines of Python script. This allows you to easily escape into whatever you can do with a regular programming language without having to build out a completely different infrastructure to deal with that. And I think like it's also like the industry is going towards there with things like Snowpark, like being able to run Python models and writing some table functions and whatnot in different programming languages. But basically, I think those approaches into bringing programming languages into these pipelines is sort of patching the existing ways of working. Whereas if you were to design them as like equally important ways of working, equally important types of primitives in the tool, it opens up different patterns and different possibilities. So it was basically a core approach that in the first version of Bruin, we had to support both SQL and Python as like first-class citizens. In the future, I can definitely see us bringing even more programming languages into these pipelines and also more tools. Maybe there's going to be like Ingester is a good example of this. It's like a standalone command line application, but we also integrated it as a type of an asset in Bruin CLI, which means data ingestion jobs are first-class citizens in the same pipeline as well. This allows enforcing data quality checks on the data ingestion jobs. This allows using them as part of the same data lineage. This allows ensuring that data is always accurate and they run in the right order without having to configure different schedules elsewhere. So long story short, treating these different technologies as first-class primitives allowed us to sort of build an abstraction that brings all of these together within the same graph, if that makes sense.
Absolutely. And digging a bit more into that transformation ecosystem, you mentioned SQL Mesh, SDF, DBT. I think SQL Mesh in particular stands out as supporting Python and SQL on a level playing field where, from my understanding, as long as your Python returns a data frame, then it treats it the same as if you were doing a SQL transformation. And so you can actually combine those different modeling patterns. I don't believe that they have facilities to be able to extend beyond Python as a full-on programming language. So it's, I believe, fairly locked into SQL and Python being those interfaces, but I'm curious if you can talk a bit more to the transformation engine that you're building, some of the ways that it's designed, and some of the juxtaposition of how it fits within that overall ecosystem of these SQL-focused transformation tools that are targeting data warehouse environments.
First of all, I love SQL Mesh as well. I think the founders are pretty cool people as well, and I think it's a really good piece of technology. And not SQL Mesh, but we use SQL Glot in Bruin CLI as well. So I think they brought in a lot of new stuff that were not there, especially with DBT before. I think an important difference that we sort of position ourselves around is there are transformation tools or transformation frameworks, whereas what we're building is a framework for working with data end to end, right? So this means that data transformation is part of what we do with Bruin CLI as well. But same for data ingestion, same for data quality, same for data governance and observability, right? So I think an important difference in terms of Bruin CLI is it's more like a data stack in a box compared to a data transformation tool as well. Now, this obviously comes with a different trade-off. For instance, the fact that, I'll give an example with SDF. I think they're building like a really interesting product with very deep understanding of what happens within SQL, and I think they do this better than we do, for sure. But what we're trying to do sort of is to go to the end-to-end of that experience to be able to cover more use cases with the good primitives and a framework around working with all of these in a different way, right? So I think like comparing transformation tools with like DBT or SQL Mesh with Bruin sort of in that sense becomes apples versus oranges. It's they sort of aim for different purposes. One of the things we are going to be doing in the next months is going to be being able to run DBT models as part of Bruin pipelines as well in the CLI in open source, right? So this allows sort of stepping a layer above the transformation tools themselves and still being able to give those primitives of having the execution graph, having the lineage, having data quality without having to change the transformation tool, right? So I think like we try to go to the breadth where they go to the depth, and we sort of at the moment we focus further on making that breadth experience as seamless as possible.
Before we dig too much more into the architecture of Bruin and some of the ecosystem that you're thinking about around that, I'm also interested in touching a little bit more on that code-only philosophy. You mentioned who you're targeting, but I'm also interested in some of the ways that code-only approach maybe acts as a gating factor for certain types of organizations, certain audiences, and especially as you expand beyond a single team and into the organization level, how you think about Bruin existing in a broader organizational ecosystem where maybe there are heterogeneous tools used. How do you allow Bruin to be able to exist within a certain microcosm of the organization without requiring everyone to be on the same tool stack?
So one of the things that we like in our first experiences bringing Bruin to customers was like that exact the wall that you mentioned. There are people that work with data, but they haven't used Git much, or they would feel much more comfortable if they had a UI that allowed them to do certain things in a certain way. But on the other hand, I genuinely believe that you cannot scale a UI-driven way of working to an organization. It just doesn't work. You'll run into a lot of troubles. So what we are trying to do to sort of reduce that barrier in terms of what we're doing is obviously we target people that still can write some amount of code. Like they should be able to write SQL or Python. I don't think we are the right tool for people that have never worked with these technologies before. But in order to reduce that barrier of entry, what we're doing is, for instance, we have also an open source VS Code extension that visualizes everything that's in your code and gives you a UI in your local device that sort of allows you to edit different parts of things. So maybe you write your SQL and you want to define like different types of columns, or you want to add some metadata. You get a little UI that helps you do these. And that UI still translates all of these different things into code in your repository, right? So we try to hit that balance of reducing that barrier to a certain extent and giving people the user interface that they can work with without losing the benefits of code first solutions. So everything you do in the UI is actually driven by the code. Everything you change is reflected immediately in the code. Code is the source of truth. It does not be the layer that you work necessarily in, right? But it is the thing that drives the rest of the infrastructure. So I think in terms of that, like sort of barrier of entry, we're trying to complement our CLI applications with little open source UIs around them as well.
So that definitely helps with the accessibility of seeing kind of what is happening without having to try and parse the code. And so now focusing a bit more on Bruin itself and the technologies, I know that Ingester is a wrapper around the DLT framework. Yeah. I'm wondering if you can just talk through the overall architecture and design of the Bruin tool chain and some of the ways that the design and scope have evolved since you first started working on it.
Absolutely. So, well, I mean, let me start with Ingester first, because that was it was a very quick thing that we ended up building and releasing as a standalone tool. So we started with transformation pipelines and then Python, and then Bruin CLI was doing all of these different bits, but we did not have proper support for native data ingestion. And this was around the time when DLT was being released, also a Berlin team, and then we have some close contact with the founders there. And we ended up giving it a spin, and it turned out to be exactly what we needed. So we were thinking of bringing DLT into Bruin. Now, little complexity there. Bruin CLI is written in Golang, which is not a very popular choice for writing data application, I guess. But we wrote everything in Go there, and we needed to bring those different Python libraries into that. And while looking into that, we thought, okay, it would have been amazing if there was a standalone executable that we could run just to ingest data so that Bruin CLI could orchestrate it in a platform agnostic way, in a language agnostic way, so we didn't have to write a lot of Python for integrating it. That's how Ingester was born. We took DLT, we sort of wrapped a command line interface around it. We made it a bit more opinionated, and we built it to solve our own problems with Bruin CLI, but ended up releasing that, and people liked it. So that's we sort of wrapped it around that. But I think that helped us a lot when integrating that into Bruin CLI as well, because essentially Bruin CLI has a mini orchestrator inside of it. It's written in Golang, it's highly parallelized, and it can execute these different binaries or executables as Docker images or binaries or natively like Python or SQL, etc. Right? So long story short, Ingester ended up being built as a standalone tool because we needed a way to run ingestion jobs without bringing Python code into the CLI. And Bruin CLI takes advantage of Ingester being a standalone tool and runs all of the other parts natively in Golang. That sometimes introduces a bit of duplicate work or hard work if you use Go for a lot of data workloads. There's not going to be libraries. You're going to have to jump through a lot of hoops. But so far we've been managing that fine. So that's a brief integration story between them.
Digging more into Ingester and harking back to that escape hatch conversation that we had, I'm wondering how the work that you did on Ingester allows for extending the different connections that you're able to build, or maybe being able to write a custom DLT pipeline and still be able to execute that either via Ingester or via the Bruin CLI.
So Ingester itself has certain sources and destinations it supports. We constantly try to expand that, but if Ingester does not support a source and you still need to get that data, you don't extend Ingester itself. Instead, Bruin CLI allows you to do all of these different things, but also in Python as well. I'll give you an example. Let's say you want to ingest data from Shopify, and Ingester supports Shopify directly. Bruin CLI supports Shopify through Ingester as well, which means you can write a few lines of YAML that will bring whatever data you need from Shopify into your data warehouse. But then let's say you want to bring data from your internal accounting platform. Then for that, you write a few lines of Python scripts that returns a data frame. and then you put it as a Python asset in Bruin, which means if you run both of these assets with Bruin CLI, Bruin will run them in parallel. It will use ingester for Shopify integration, and then run your own ingestion logic, and then upload the resulting data frame into your data warehouse for you without you having to write any extra code for it, right? So the moment that you want to step outside of just like a single data ingestion job and you want to build that pipeline, that escape hatch lives inside Bruin CLI. In practice, it means that your pipeline is going to be usually a combination of ingester tasks, SQL assets, and Python assets that either bring data in or even do a reverse ETL at the end of your pipeline. And I think it's a good way to show that I think we're on the right path in terms of the primitives, because using the same Python assets and Python primitives, you can use them both for data ingestion, but you can also push data to another API that you need to integrate with, right? Or you can train a machine learning model, or you can do predictions, or you can communicate with external APIs, you can send notifications and all that kind of stuff. Basically having that flexibility right within your pipeline. I think that's how I would think about that escape hatch and expanding the ways of working there.
Another aspect to talking to being able to move beyond the bounds of what is explicitly in scope of the tool design. You mentioned Bruin is focused primarily on that analytical use case. And so for teams who they've used Bruin, they've got their analytics in a good space, and now they're starting to explore more sophisticated applications of data, or maybe they're doing reverse ETL for data operationalization, or they're starting to look more into machine learning workflows that require a different element of orchestration. I'm wondering how you see Bruin sitting in that overall data ecosystem for that company, and some of the ways that the insights that you get from Bruin are able to be brought into those other contexts where maybe you have to use the lineage information from Bruin and populate that into another more overarching metadata tool to be able to get that full end-to-end lineage as you go beyond those analytical use cases, and just some of the ways that you're thinking about those design challenges.
I think like one of the things that we took, we try to make sure that Bruin never locks anyone in. And while it has ways of working, it integrates with other tools as well. I think you gave a good example with metadata store, right? Let's say you have certain Bruin assets, but you also use Atlan as your data catalog, because you have, like, I don't know, tens of different sources of like types of data, and you catalog everything there. So we have built a dedicated metadata push feature into Bruin CLI, which allows taking all of those definitions in your assets and pushing them to configured external metadata stores. The first thing we built for this was BigQuery integration, because customers wanted to replicate the documentation they have in their assets on BigQuery as well, so that they had some other analysts they don't have to leave their BigQuery UI. That means that without having to duplicate any documentation effort or doing any manual work, with a single checkbox in the VS Code UI or a flag in the command line application, they could simply push the same metadata and replicate them in an external platform. Another way that we unlock this is Bruin CLI has internal commands that allow you to have a JSON representation of the whole pipeline and assets, right? Which means if you wanted to run Bruin CLI elsewhere, like let's say you start with GitHub Actions, now you're moving towards a different architecture, you want to run it as part of another orchestrator anywhere else, you could simply parse all of these definitions, convert them into the primitives of the orchestrator you're using, like Airflow tasks or Daxter assets, that you can get all of those benefits without losing the benefits of quickly working and iterating on these workflows locally. I don't think we're there that we can integrate with every tool out there, but we're simply trying to build things in such a way that if we're not integrated yet, it should still have the possibility to integrate in the future, just building that missing piece of integration. In terms of that metadata push, for instance, we support BigQuery at the moment, but there's nothing limiting us to support Atlan or Confluence even, or any other data catalog anyone might be using. Thinking of like ML workflows and things like that, we are currently working on expanding Bruin's Python abilities, where you do not have to run Python in the same device that you're running Bruin CLI, right? So for instance, you could still have your Python assets, but you can run them as ECS tasks on your AWS account remotely. Still, you get to work locally. If you want, you can run those locally, or if you have a dedicated infrastructure that you need more, I don't know, you need GPUs, you need bigger instances, you can still run them remotely, right? So goes back to the first principles we built Bruin CLI around. We do not lock anyone in. I cannot hold people locked in. It just doesn't make sense for anyone, and I hate that personally as well. So that's why we try to build those like little integration points, I would say.
Now, for people who are looking at Bruin, they're trying to figure out, okay, this looks like a useful tool. How do I build with it? Can you just talk us through a typical workflow of going from, I have some data that I have in a source system. I want to build a dashboard based on some transformed version of it, or I have multiple sources. I need to aggregate them together, build some sort of a, maybe a snowflake model or a star schema in my data warehouse, and then start generating dashboards on top of that, how that looks in the Bruin native workflow.
Yeah. So one of the things that I think I find very helpful when I'm working is to have like those starting points, like templates. That's why we have built a bunch of templates into Bruin. I'll give an example. I think Shopify is a good example. Let's say you have a Shopify store that you want to pull data into Snowflake, and then you have an internal Postgres database that you want to bring that data into Snowflake as well, and then you're going to mix and combine these bits of data, right? The first thing you do is you install Bruin in your computer, and then you can simply run Bruin init Shopify BigQuery, and it's going to bring a pre-built Shopify pipeline with data ingestion assets defined, which will automatically bring that data from Shopify into your data warehouse. It will have a few steps of instructions in them. So you set the connections here. Here's where you here's how you run the asset. Here's how you can run the whole pipeline. And that simply allows within seconds to have a pipeline that brings Shopify data into your BigQuery data warehouse with a single command execution, right? And then let's say you want to bring your Postgres data as well. You can simply copy one of those Shopify assets, just change the source to be Postgres instead of Shopify, add those credentials into your Bruin YAML definitions, and you simply have your data being replicated as well. As part of these templates, you also get some SQL assets, which sort of show you how exactly how you can run SQL assets in that pipeline. In the examples of pre-built sources, we try to model the data, we try to clean the data and give you like a full end-to-end pipeline. But if you want to build your own transformations, effectively you write your SQL, you put a few lines of metadata at the top of the same file, you can use these templates as like a starting point, and then the moment that you hit run, it's going to run them as part of the pipeline again. You have the ability to validate all of these configurations. For SQL assets, we do extra validations using the data warehouse, so sort of running them as part of a dry run execution to ensure that there's no semantic errors or there's no data errors in the assets itself. And then this already becomes a production-ready pipeline for you, right? Run it in GitHub Actions using our GitHub Actions scripts, or you can run them in Airflow. You can run them in Dagster. You can run them in a cron job in an EC2 instance. You could use Bruin Cloud. Just pick the best tool that you're familiar with, basically. So this would be the way of working, and then gradually expand from there.
As you continue building and investing in Bruin and building the open source components of it, I'm wondering what your thoughts are as to how you are considering the overall ecosystem around it. Are you looking to build your own ecosystem for Bruin? Are you looking for Bruin to be part of another ecosystem, and just some of the ways that the sustainability and the multiplicative factors of being able to take advantage of other components in other tool chains, how that factors into what you're designing with Bruin?
That's a tough question, because we want to build an ecosystem around Bruin, but we do not want to having to build everything from scratch, right? We want to be able to benefit from existing advancements in other industries as well. I'll give you a couple examples. Data ingestion. Ingester just wraps DLT, and we try to contribute back to DLT as well, which means any advancements in DLT itself in terms of making data ingestion faster, more efficient, supporting more sources and destinations, Bruin users start getting those benefits right away as well without having to rebuild everything from scratch. Another example we try to make use of those existing stuff is SQL parsing. It's a very nasty job. You have like tons of dialects that you have to support, and in Go, there's not really a solid library that does that. You know, we thought, okay, well, we could build this from scratch. We can do all of that thing, but that would be like a big undertaking, and well, maybe we're not the best programmers out there, yeah? So there's some more clever people than us that did that before. So we figure out a way of integrating Python libraries into our Golang application in an embedded way. So without anyone having to install anything extra, we can use SQL Glot as part of Bruin CLI, which means any advancements we get out of those like different tools, we replicate them in Bruin as well. Now, this opens up the question that, okay, are we going to have to build everything from scratch, or are we going to have to like the community has to figure out all of these different additional new features that need to be brought into Bruin, or could we integrate with existing ecosystems like dbt packages, for instance? I don't know. I think we'll see over time. I do not see a very straightforward way that we can bring things like dbt packages into it. But I think the fact that we can run everything as native Python assets means that people can use any library they want, and they're not limited with what we can do, you know? And that's one of the things that I like about running Python natively instead of relying on things like Snowpark. You're not limited to what that environment can run. You can pick what you're running. You can build your own environment to run all of these different assets that gives you full control in terms of the ability and the escape hatch, the depth of the escape hatch that you want to build, you know? So long story short, a couple of ways that we integrate. Longer term, I don't know. We'll see. But if anyone has any ideas, I'll definitely love to hear.
And on that note, from the open source and community building side of things, what are the main opportunities for contributions to Bruin and Ingester, and some of the ways that you're thinking about the developer onboarding experience for people who want to build onto or extend those utilities?
So for all of our open source projects, we try to make getting started that simple, especially with like some pre-build commands that they can simply run to install dependencies and run tests and build the application, etc. For around Ingester, the first thing could be and should be that we recommend people to do is, if this is like a common source or a destination that would benefit everyone, let's contribute back to DLT itself instead. So the wider community gets the benefit of that new integration as well, and anyone can use them in their infrastructure. Then we can replicate that in Ingester as well. For Bruin CLI, I think, well, we are just opening up the tool to public use, like releasing it in the open source. So there's probably going to be a lot of missing pieces around documentation and sort of like getting started bits. We try to improve on all of those fronts, but it could be painful for first-time contributors to understand what they do. But at least I'm more than happy to, you know, give people support when they wanted to contribute. We do this in a couple of ways, but the primary way we communicate with the community is we have like a public Slack channel that people can join, that we try to have personal touch. The other day, I hopped on a call with a contributor that I've never met before. We just did a quick fix together, so I really like that kind of stuff, and I'm more than happy to have any contributors in what we're doing, what we're building there as well.
And in your work of building Bruin, building Ingester, and building the business around them, I'm curious to hear about some of the most interesting or innovative or unexpected ways that you've seen those tool chains and workflows applied.
Well, there was one person that built like a COVID analysis, like a full pipeline using Bruin in his free time to build like in like a case analysis and building summaries around that. Someone did a case study for one of our customers. Like the case study was like asking them to build like a data transformation pipeline, and they built it in Bruin, even though we have not launched any of these in publicly, but they found some public repositories and they figured out all of these by themselves. And I think, generally speaking, anything that sort of goes beyond regular analytical jobs and people like seeing that people use Bruin stuff and outside of those, I think has been pretty interesting. One example that pops to mind is one of our customers started using Ingester as like a reverse ETL. So they load data from Postgres to BigQuery. They do a lot of analysis on BigQuery. They do like build a lot of other data transformations. But at the end of it, they use Ingester again, this time BigQuery being the source, Postgres being the destination. They replicate that data into their production database so their API can serve this new transformed way of data, which was something sounds so obvious looking back now, but was not what I had in mind when we were first releasing Ingester. So I really enjoy discovering these kinds of clever uses of what we're doing. And it also gives me hope that these are primitives that allows people to build those like flexible workflows that allows them to like run all of their production workloads on Bruin while also doing like fun analysis projects over the weekend using the same primitives.
And in your work of building these tool chains, working with the community, understanding the problem space, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
One of the things that I found challenging was I come from software background. A lot of the practices that we built into Bruin was like had its roots in our software experience. And some of those patterns are not very obvious to people that have been working with data, especially people that have just spent like a year or two working as a data analyst. And I had this reaction that, okay, we're going to help you figure out how to work with these tools, and that will help you get faster. In the end, we ended up learning a lot more from them, where they figured out, they sort of came up with such interesting problems that we were like, oh shit, we have not thought about that at all. We had no idea that this was a problem. And this has been overall an eye-opening experience and has significantly changed the direction for us in terms of the type of tool we're building. Initially, it was very focused on data analysts, data scientists, but command line applications, people that are comfortable with terminals and stuff. But over time, it significantly shifted our focus to, okay, still those same primitives, but make it as easy as possible, give them the right extensions, meet them what they need to, where they need to go. Yeah, so sort of give them those tools that or patterns that are used to it. I don't know if this answers your question, but
yes. Well, it's more just a matter of your own learnings, your own kind of takeaways from going along this journey to where you are now.
A very important learning in this process for me was people, when they built like any sort of workflow where they have to do the same job repeatedly, but like in slightly different ways, and they start introducing a lot of tech debt into the process. I always thought that it was like, okay, they don't care, they don't care about building sustainable stuff, or they don't want to do the right thing. It has been an important learning for me that has nothing to do with whether or not they care. It's just as simple as they do not have the right tools to do the right thing. So the moment that you give them the right guidance and you make doing the right thing also the easy thing, it significantly changes the way people work. And I think that reflects itself in a lot of these different tools that I think pretty much all of us are trying to do the same thing, give these people the way to do the right thing and also make it the easy way to do the same thing, so they do not pick another way and make things worse off. That has been an important learning for me that shifted how we think about our products constantly.
And for people who are looking for a tool stack, they're trying to manage their analytical workflows, what are the cases where Bruin is the wrong choice?
Very good question. So one of the decisions we made early on was dynamic pipelines, where let's say you ingest your own customers' data, and as you bring in new customers, you're going to have to run the same workflow but in parallel for like 100 customers, 200 customers, basically replicating, dynamically generating pipelines. Those use cases, Bruin is not the right tool, is not the right solution for that. So we do have certain primitives around dynamic pipelines, but dynamically generating assets, for instance, like you could do with Airflow or Daxter, I think Bruin would not be the right tool, and instead you should go for a full-blown orchestrator that has those capabilities for those. The second use case, I think that we are not a good fit is ML-only workflows. We have a lot of focus on analytical pipelines where you see like roughly equal, if not more SQL-heavy distribution among SQL and Python assets. But in ML world, that would be a completely different thing, where data quality concerns do not really apply exactly. You have much different observability requirements. So for those like ML heavy pipelines and ML workflows primarily, I do not think Bruin is the right solution. And I think these are the ones that I think people should be considerate of when picking.
You mentioned a little bit about some of the future direction that you're thinking about, but I'm wondering if you can talk to some of the near to medium term plans that you have for the project, for the business, and some of the projects or problem areas you're excited to explore.
So a couple of different avenues we're going down are, first of all, the templates that I mentioned. Getting started is usually the hardest part, and the fact that we have those primitives for data ingestion transformation means that we can actually build full-blown templates that allows analyzing data, building data models within seconds for any platform out there, right? So we're going to be investing heavily into expanding our sets of templates to sort of make it Bruin like a tiny marketplace of templates that people can choose and start building upon. The second avenue that we're chasing at the moment is getting deeper into understanding the semantics of all of these assets. So for instance, Bruin CLI parses your SQL definitions, and it's going to get columns out of that. It's going to build your dependency tree, etc. But I think there's a lot more static analysis capabilities that we could introduce into those workflows that expands beyond SQL, but also combining them with data ingestion. So those kinds of like lineage / static analysis capabilities is one of those things that we're going to be investing further into. And the third avenue is execution freedom, where if you want to execute your code elsewhere when you're running your Bruin pipeline, those transformations that needs to run closer to the data, or they need to run in a beefier machine or elsewhere, simply we want to be able to support those remote execution capabilities in Bruin pipelines. And beyond all of those, I think we want to make sure that we also offer the best experience as like an offering, like a managed platform to run all of these as well, where people can decide where do they want to run their transformation workloads, and they don't have to think about any infrastructure to manage all those. But that's a bit more on the business side of things, So I would say these are the current things that we are looking into in the next months.
Are there any other aspects of the work that you're doing at Bruin, the overall space of code-only data pipelines, the problem areas of building these analytical systems that we didn't discuss yet that you'd like to cover before we close out the show?
Well, there's one little piece where I always wished people built like code-driven BI tools as well, right? Where we see new developments around there with tools like Evidence, or some of the tools are going into that space as well. But I would really love to see more developments there so that we can integrate with those kinds of solutions to give like a real end-to-end experience there with regards to from ingestion till the insight being actually used elsewhere. I'm hoping someone builds more solutions in that space. Other than that, really appreciate you having me. Thanks for having me on the show. And it was really lovely to chat.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And so as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technologies that's available for data management today.
I think the biggest gap, the thing that frustrates me the most especially, is data quality being treated as a second-class citizen, where people run all of their transformations in somewhere. They have their orchestrators and data ingestion jobs, and then you have a completely separate place that runs data quality, which means it becomes an afterthought. And I think data quality especially as organizations use data more, teams get bigger, teams rely on the data more and more, data quality needs to be a first-class citizen. I think software teams sort of internalize this by now, where like companies with solid engineering cultures in the software side are going to be always implementing some form of testing and validation and integration tests and whatnot. I am really looking forward to that being a common approach in data teams as well, where data quality is a first-class citizen in every workflow that people are building, and it becomes like one of the first things people talk about.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing on Bruin and some of the ways that you're thinking about how to simplify and consolidate the workflows of people building analytical systems. I appreciate all the time and energy that you're putting into that and making the tooling available for folks to be able to build on top of it. And I hope you enjoy the rest of your day.
Tobias, thank you very much. I appreciate you having me here, and thank you all for listening as well.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.